Hi, and welcome to a Level 1 algebra video on simultaneous equations. Now, simultaneous equations are equations that are happening at the same time. We have two equations and we have two unknowns. We often use the variables x and y to represent the unknown. We're going to learn two strategies to solve these. The first strategy in this video is called substitution, and the second strategy in our next video is called elimination. Right, here's example 1. Find the solution of the pair of simultaneous equations. The first equation, y is equal to 2x minus 7, and the second equation, 2x plus 3y is equal to 11. Now, if we see a pair of simultaneous equations where one of the equations is written as y equal to something, we're going to grab that something, 2x minus 7, and we're going to substitute that into the y in the second equation. That's why the method is called substitution. So I'm going to write down my second equation, 2x plus 3 times y, but I'm not going to write down y, I'm going to write down 2x minus 7, and that's all going to be equal to 11. Now we're just going to solve this equation. So to do that, let's expand out the bracket. 3 times 2x is 6x, and 3 times minus 7 is minus 21, and that's all equal to 11. We can simplify the 2x plus 6x to make 8x. And now we've got the minus 21, so we can get rid of the minus 21 by adding 21 to both sides, and that leaves us with 8x on the left, and 11 plus 21 on the right is 32. Now finally we get to divide everything by 8, and that leaves us with x is equal to the value of 4. So we know the first variable is x, and that's equal to 4. We need to go back and find out the value for y as well. Now we could use any of the two equations we've been given at the start. I like to use the one that has y equal to something. So let's use this equation, and let's grab the x value of 4 and substitute that into this expression. So y is equal to 2 times x, or 2 times 4 minus 7. 2 times 4 is 8. 8 minus 7 is equal to 1. So we now know y is equal to 1. And we've solved the equation. We know the solution to the pair of simultaneous equations is the point 4, 1. The x value is 4 and the y value is 1. Now notice I've written it as a coordinate because that is the solution to the equation. And let me explain with the graph. Here's our Cartesian plane. Let's take the first equation, y equal to 2x minus 7. I'm hoping you've done some work on straight line graphs by now. This is a straight line graph. Here it is here. It has a gradient of 2, which means it rises up 2 and runs across 1, and it has a y-intercept of minus 7, so it passes the y-axis at negative 7. Now our second equation is a bit more trickier to deal with. It's still a straight line graph. Here it is here, but let's quickly explain how it is. Let's rearrange the graph. The first thing I'm going to do is subtract 2x off both sides to get 3y equal to 11 minus 2x. Now I'm going to swap the minus 2x and 11 over, and now I'm going to divide everything by 3 to get y is equal to minus 2 over 3 times x plus 11 over 3. Now, when I write it like this, keep in mind that I could also write it as minus y equal to minus 2x all over 3 plus 11 over 3, or I could write it as y equal to minus 2 over 3 times x plus 11 over 3. All three of those equations are written in the same way, even though they're written differently. Right, well, this is just a straight line graph. You can see that it has a gradient of negative 2 over 3, so it rises down 2 and runs across 3. And it has a y-intercept of 11 over 3. 11 divided by 3 is around about 3.67. All right, well, I've got my two straight line graphs, and you can see clearly that the answer to our simultaneous equations is where those two straight lines meet, the coordinate of where they meet. All right, thank you so much for watching.